All right, well, welcome to this afternoon's session, Communication in a Satellite-Denied Environment. This is pretty exciting for us to do this. ACI has been, we've got given the mission from G3 a couple years ago to take a look at HF, and that was as much as I was told. So we took that and did a lot of work with it, but I have some excellent panelists that were able to join us on this and talk about some aspects of kind of the opposite, I guess, of the last panel. So the last panel with 5G, we're looking at the really high end of the spectrum, and you heard like 60 gigahertz. In high frequency range, you're looking at 3 to 30 megahertz, so much lower frequency, but it's a real different animal than dealing with the high frequencies, because you do cool things like bounce it off the ionosphere. I think that's pretty cool. So, but I'll introduce our panelists, or they'll introduce themselves. I'll have start with John Rosica from Nivis Communications.
Good afternoon. Thank you for the opportunity to be here today. My company is NVIS Communications, and we're a system integrator based in California. We deal heavily with fallback, failover, and resilience communications, voice and data, using the medium that the Colonel talked about. Our mantra is less is more. And I serve also as the HF Industry Association co-chairman worldwide. So it's my second term. I've had a chance to work with militaries from all of Indo-PACOM and serve as a subject matter expert at various different communications interoperability events throughout Indo-PACOM. So I've had a unique opportunity to see how the medium is used, still used, and becoming more used for the very reason that this event is here, cyber-denied environment of one of the many reasons. So very pleased to be here and hopefully can provide some good information for you.
Okay, and then we also have Ross Merlin from the SHARES program.
Hi, I'm Ross Merlin from the Department of Homeland Security's Shared Resources HF radio program. I'm the program manager for a program that currently has about 2,500 participants throughout the United States, all levels of government, all military services, federal civilian agencies, state and county emergency management agencies, and critical infrastructure key resources. This program is for backup communications, for interoperability, and for data communications. So, imagine if there's no internet, no telephone, how do you stay in business? How do you get your mission done? My mission is to help you do your mission.
All right, and then we have Vic from Communication Systems Research Group.
Thanks so much. Hi, everybody. Thanks for having me, Colonel. My background is 20 plus years in strategic and nuclear command and control and continuity. So that's my perspective. My perspective is more operational. How do we do it today? How do we do it 5 years from now? But more importantly, how do we do it strategically? How does everybody work together? And so that's about it. Okay,
great. So as I mentioned, ACI has been doing a little bit of research in this for the past about a year and a half, maybe 2 years now. And it started, like I said, with just this kind of charge of let's look at HF. And then we said, well, why do we want to look at HF? Well, it's because of this. I think now if we look at a near-peer threat, we have to figure out how do we operate in these degraded environments. What happens if our satellites get taken down? What happens if we lose the ability to communicate beyond the line of sight? And we look back to the Cold War, because we used to do this before. We did it with HF radio. Now, HF radio, as some of you may know, is not like any other kind of radio, because when you pick up a radio and you just transmit, and you just like we use a lot of radio, there's a radio on me right now, I'm transmitting across, that's usually done line of sight. So to do beyond the line of sight, you have to do something more interesting, like bounce the signal off of the ionosphere. And that can get you incredibly long ranges, and it doesn't require the use of a satellite. Could it be jammed? Yes, it obviously could be, but it's a lot harder to take out the ionosphere, I think, than it is to take out a satellite. So it's something that we've been looking at of like, basically, how do we learn to use this as an emergency backup for in the case that we need to still communicate? So there's a lot of challenges with it. I think one of the ones that I always have to focus on, and I'm more of a hobbyist when it comes to HF radio with amateur radio, but looking at your antenna is like incredibly important, and what type of antenna you use. All of these factors have like a huge impact on how you're communicating and where you're trying to communicate to. So one of the challenges that comes up is is low bandwidth. So we probably heard the rat rigs back in the day. There's some old school digital communications that we used to do. There's been some advances that are kind of going, I guess, more behind the scenes is what I would say, because you haven't really, we've been focused so much on satellite communications, at least the Army has in the last 2 decades, that we've kind of let our HF abilities kind of atrophy. But during that time, there's still been a lot of research and progress in digital communications. But there is one thing that I'll have Vic talk about first is what do we do, how do we operate on HF with digital modes? Because the digital modes that we're talking about we're not doing a VTC. We're talking about more, I would say, text messaging, or slow scan TV is what you see in ham radio, where it's like it takes a few minutes, but you can send like one picture, maybe a map or a graphic.
Sure. So that's, I think, one of the big challenges is in the HF world. They talk about wideband, high data rate. The thing is that high data rate's relative. So in regular landline world, right? So at the access layer, we're talking 1 gigabit. At the core, 100, 200. I think they have now 400 gigabit. So now when you're going back to this HF low bandwidth stuff, I mean, you're talking 75 bits per second, 2.4K, and even the wideband that you hear about, this high capacity stuff at best is 256 maybe. And oh, by the way, most of it's half duplex. So for the IT guys in the room, you appreciate what half duplex does to your applications and your network architecture. So the challenge with a lot of this isn't really technical so much as it is operational. It's how do you train the staffs to concisely convey information? Because that's the biggest problem that we've seen, is that when we send messages out and we talk to people, everybody now is used to conveying information with a 25 megabyte PowerPoint slide of 50 slides. And so if the commander has to send out a sit rep, how many of the folks still know how to do that? If you have to send an order to take the hill, do you need to have a VTC to say take the hill? Or can you just have a short text message or a voice message that says take the hill? And so the challenge is that we need to rethink how we're going to communicate in both satellite-denied and cyber-denied environments, or bandwidth-constrained environments, because believe it or not, it is a skill, and I think that's a really important piece of that.
Yeah. Okay. So great. So the digital modes you say are low data rate, but I guess there's also been some advances in codecs, which are ways you can take voice and convert it into digital. And we've luckily had John come up to ACI and do some testing with us, and we've seen some pretty interesting things. So John, could you tell us a little bit about digital voice and
Sure.
how that works and compares to like single sideband old school voice?
Sure. Thank you. So the first thing to keep in the back of your mind when you're talking about anything to do with HF is the mantra should be less is more. And how do you do more with less? And anybody in the room here that is either fortunate enough to have no hair like me or gray hair like Ross and me, you probably know HF in some way, shape, or form. And among all the other difficulties to using the medium, manual controls and highly skilled nerds at every location that you have a HF radio to be able to conduct your business, the voice sounded terrible. Sounded like Donald Duck, and it had a lot of background noise. So if you were doing any kind of radio telephone radio wire interface, that noise went through the circuit, and so you know what it sounded like. Probably one of the single greatest advances in voice circuits for HF in the last few years has been the ability to digitize the voice. It's always been there in the past. The problem was you paid a huge penalty if you were going to digitize the voice, because the codecs required a very high signal-to-noise ratio to work. So that meant they only worked if you had gobs of power, huge antennas, and fixed location to fixed location. What has happened in the last few years with, there's a term that you might have seen floating around here called MELP. It's an algorithm, MELP. Don't worry about what it means, you can look it up. But what it has brought forth is the ability to digitize and transmit your voice over HF circuits, in fact, better than the ability to do it just in the clear. The quality of the voice is as good as an FM radio or phone call, cell phone call quality, and the ability for that voice traffic to get through over great, great distances where even in the absence of that digital codec, you would not hear the other side, which is just unbelievable. Because before, you always would fall back to the worst possible scenario. Nothing works, so you just put the radio in clear, what we called sideband, and you said whatever you said, and the other side had to have a trained radio ear to listen to your voice in a Donald Duck-esque type sound, and with a whole lot of popping and static and so forth in the background. That's all gone away. We've improved the quality immensely, and we've improved the range on the circuit because of the codec being so narrow that we're, instead of transmitting the wide spectrum of the human voice, or the part of it that we're going to transmit, it isn't exactly the 20 to 20 hertz or 20 kilohertz. It's so narrow that it gets through, and you cannot even hear anything intelligible without that. And that's probably a significant improvement in the voice traffic capabilities.
Yeah, it's pretty awesome. You were up, I guess, a couple of weeks ago, I think, at ACI, and we did some testing. And I think we went to your station in Virginia, I believe.
Yes.
So it was cool because we actually used the internet. The internet's actually been a big help. I know ham operators thought it was going to kill off the amateur radio for a long time, but oddly enough, it's actually been a huge help because now we can do better testing than we could before. And in this case, we had I guess it was kind of like a voice over IP link back to,
Yes.
in a sense, back to your station in Virginia. So we could talk through it and then hear it come out the other end. And it was really surprising because we did single sideband voice and it just did not make it through. You could not, it was unintelligible. And then we did the digital voice and it came through like perfectly clear. So it's kind of amazing with these digital modes and some of the modulation techniques that are being employed. And in fact, we did a test at NTC, I think it was within the last year, where we were just trying to figure out how to do NIVIS communication, which is you're just trying to go basically near vertical incident skywaves. So you're going a very small distance, but over some object that you can't talk through on regular line of sight comms. So in this case, it was Tefert Mountain, and we couldn't do VHF comms. We proved that we couldn't do it, and then we did a voice shot over the mountain. We could do it easily at like 100 watts, and then we went down to about 50 watts. It was fine. But then we had to switch to digital modes to get to do better than that. And we got all the way down to 100 milliwatts, which is insane to me. It was like we've been talking about, it was low bandwidth. I mean, it was like a character a second, but it made it through, and it was 100% copy, and it was also error corrected. So really, really impressive. That's some of the amateur radio modes, FT8 if you want to look it up. Joe Taylor is a Nobel physicist who helped guide the engineering of that protocol. And I think FT4 just came out. I just made a contact on that the other day. So it's really impressive where the ham community has actually done a lot to really kind of advance the science behind using HF. So with that, going to the government side of things, Ross, could you tell us a little bit about the SHARES program?
Well, thanks. The SHARES program started with the National Communications System, which was under Defense Communications Agency and later Defense Information Systems Agency. So it is capable of meeting aspects of military mission. The program got moved to the Department of Homeland Security in 2003, and now we focus on all aspects of government, not just federal, as we were originally chartered, but we can support state and local for emergency management. The key factor, if you're not familiar with HF radio, what's so interesting and important and unique about it is you can talk hundreds or thousands of miles by radio with no infrastructure in between that you're dependent upon. Okay, with the cell phone, I can call Japan, but I'm dependent on lots of infrastructure. There's a radio tower near me, then it goes into the wireline circuit, goes across the country, fiber, there's electric power required for repeaters, there's switches and routers, and if any of that breaks, it's outside my ability to repair it. But I could also talk with a modest HF radio to Japan or California or Pennsylvania or wherever I need to go with the amount of power in that light bulb. Instead of squeezing that amount of electricity into a light bulb, I put it on a simple wire antenna and I can talk hundreds or thousands of miles. And as long as the equipment on the other end is working, there's nothing to break. There's the ionosphere. If it were disrupted by electromagnetic pulse, There's new ions arriving every day from the sun. It's self-healing. So you may have a brief outage, maybe a couple of hours, maybe even a day, but it's fixed. You're not dependent upon trucks and crews to get there. So with the Shares HF radio program, the name comes from the word shared resources. And among the resources we have to share are radio frequencies. There's not enough to go around, spectrum is scarce, so we have a pool of frequencies, 141 channels assigned to the Department of Homeland Security that we share with any agency, any critical infrastructure provider that wants to register with this program. We have regularly scheduled nets where people meet on the air on a certain channel at a certain time to maintain operator proficiency, to make sure your equipment is working, and to make sure that the operators know the proper techniques as well as how to operate the equipment. So we provide this training and testing opportunity, and we provide commonality. You know, the problem with public safety radio that was addressed a few years ago was, why can't we talk? We all have radios, why can't we talk to each other? Well, in HF, single sideband voice radios are inherently interoperable. There's really only one flavor of that, but in order to talk, we have to be on the same radio frequency, the same channel. So the Shares program provides a solution where DHS does the overhead necessary to keep those channels assigned, and at no cost to any of the program participants, you can use those channels if you need them. If your channels are jammed, come over and use the Shares channels. If you want interoperability with someone who's not normally on your channels, this is a common meeting place where you're both authorized. You don't have to do memorandum of understanding and get all kinds of bureaucrats involved. You just register in the program. You have the legal authority to use these channels to talk to each other when you need it. So within DoD, you have lots of frequency assignments. You're very self-sufficient. But if you need to talk to the State Emergency Operations Center, or you need to talk to Verizon or AT&T or any of the commercial providers, they're not on your radio channels. They're on the Shares radio channels, and you can be there, exchange what information you need, and go off and execute your mission. We also try to share excess equipment. So if someone has something that they don't need anymore but still usable, they can let me know about that. We'll advertise that to the 2,500 member stations. If they're a federal agency, you can transfer the property. If they're not federal, if you want to transfer it to me, you can, and then I'll issue it to them on a hand receipt. So it's still government property, but our non-government partners or non-federal partners can have use of it so that they're there when you want to talk to them. It's not only voice, but also data. Now, you have to manage your expectations, or let me put it the way I advise my wife. I tell her that the key to her happiness lies in lowering her expectations, especially for me that do things around the house. So that the same is true for HF radio data communications. You're not surfing the internet. You don't have gigabit to the desktop anymore. You have dial-up modem speeds. 1,200, 3,600 bit per second, maybe 9,600 bit per second on a good day with normal voice grade equipment. So you can send messages back and forth, text messages. You can send attached files. You can send binary files. If you need encryption, you can encrypt your data. If you're dealing with the civilian agencies, you can use offline GOTS software. DoD developed Transec and Encryption Wizard. Our civilian partners can use that. You just exchange keys. We establish a standard key in the Shares program that all participants have. You have a way to encrypt your data to at least the privacy level. You can use AES 256 encryption, which most commercial vendors offer to protect at least privacy level. So if you can do your mission in the clear, you can. If you want to do encryption, there's a low-cost solution. If you have type 1 encryption for your mission, you can use that on the Shares program. Most of the participants won't have that, but you work it out with who you want to communicate with. You've got the full range of options there. Thank you.
Okay, great, thanks. So the Shares program is a government program. There's also another program called Military Affiliate Radio System, which is the MARS. We have a licensed MARS station at West Point. AAM2P is our call sign. We have competed in the Noble Skywave. They do a Canadian military exercise as well. But I'd like to hear, John is also a member of Mars. I'd like to hear your thoughts on Mars. And then also if you could talk with Ross about how does Mars and shares operate together?
Yes. So being this is predominantly a military type conference, I wanted to remind everybody that the United States and all of our allies fought and won a global war in World War II, and the Japanese, Germans, and unfortunately the Italians. I'm Italian, and that was a dumb decision on their part. But they fought and lost a global war, and the complete total command and control communications that were used on the scale that those wars were, which the likes of which we've never seen again and hope we never do, were fought and won and lost in the case of the Axis with 300 baud RTTY or radio teletype on HF radio. Just always remember that. There was none of the technologies we have today. So as Vic said at the very beginning here, it's not enough that you understand what HF radio is. It's been around forever. It has improved immensely in the terms of the way it's used and the automation that's allowed it to be used by more non-skilled users so it can scale out in more places. But it's also the policies and the procedures and the command and control policies and procedures that you use when you go down to that level for whatever reason you're there, which is everything from you have no communications just normally because you're out in the middle of nowhere to you had all kinds of communications all the way up to 5G, but they were blown up, bombed, jammed, cyber interfered with, or any or all of those features, and now you're down to having to use this medium. The Mars program, which actually Colonel had it almost right, they changed it just a few years ago to Military Auxiliary Radio Service to fall more in line with its mission for the DoD, represents in the early days of radio, back to World War I, when radio first came on the scene, a plethora of skilled radio nerds like me that were used by the military to train radio operators on how radio worked and how to deploy it in a military environment in World War I, all the way to World War II, where most of the radio spectrum was actually shut down, other than broadcasts, of course, and any commercial use was restricted all through World War II. But the volunteers or skilled operators that fell into this program, some were in the military, some weren't, that fell into this military auxiliary program were used to continue to support the training of the military in the use of communications techniques, all the way to Vietnam, roughly, and a little bit beyond, where the program was used for health and welfare messaging. Today, it has a very, very different mission. I can say that it is a very large, along the numbers that Ross mentioned, maybe slightly less than 2,000, distributed body of equipped and skilled operators that perform both class and unclassed mission for the DoD, whether you know it or not. And it's a very effective program that uses encryption, data, mostly data today with some voice. And I'll defer to Vic here on my left for more detail on it, but it's a very, very effective program for a number of reasons that's existing today. It's always existed, but its mission changed quite drastically in the last 5 to 7 years to support a very important DoD mission. So it's something you may not know about, but you may, in one way or another, touch it at some point in your career if you're in communications or in the G6, and it's important that you know what it is and what it's there to do. And
So what I can add to it is there's a couple reasons why the DoD looked at everything and said, oh wow, we're going to use the Mars program. Really 2 reasons. One was technical. While there's HF capability sporadically around the services, following the end of the Cold War, really this concept of a holistic strategic network went away. And so while you had pockets of capability, those pockets of capability could not talk to each other. And so one of the benefits of the Mars programs, there's an Air Force program and an Army program. One of the benefits of the program was that it's all mil standard interoperable, so everybody could talk to everybody. that was sort of the first piece, which was technical. The second one was really a personnel issue, is that if you go look around the DoD and say, well, hey, who can get on a radio and actually communicate information, kind of like I talked about at the beginning, what we found is that was a very lacking skill. And that organization, or those programs still retained the capability to do that. They still had knowledgeable folks that understood what a mil standard 6040 US MTF message was. They understood what a commander sitrep message was. As kind of Ross pointed out, this is not PowerPoint attachments. It's not a lot of bandwidth intensive communications, but they're basic communications that work and folks who understand it. So that's why those programs are very important today.
Okay, so for the SHARES program, in some respects, it's like a civilian version of the MARS program, but there's a couple important differences. The MARS program exists to execute a specific military mission, support to the military units. The SHARES program is supporting all of government, including military, but also the civilian side of it and the industry side of it. Critical infrastructure, key resources, electric companies, water companies, cell phone companies, telephone companies, internet companies, a lot of hospitals, some transportation companies are involved. Anything that you would consider critical infrastructure or key resources, we can support that. The MARS program recruits amateur radio operators, ham radio operators, as the primary resource. Military personnel, you can have stations on military bases, but it's primarily civilian volunteers. In the SHARES program, we're not competing with our MARS partners for the same pool of people. We're not recruiting ham radio operators. We love them, we respect them. We couldn't have a program without them, but we're going for the government entities and critical industries, the folks who would originate or receive an emergency message. The role for volunteers in our program would be as relay station. And I have hundreds of relay stations, the MARS members. If you're a MARS member, you're automatically eligible to be in the SHARES program because I know you're well-trained and you'll probably follow orders or instructions, as opposed to ham radio operators in general, which the phrase herding cats was originated by a ham radio operator, and that there's a lot of freedom in the ham radio culture and a lot of innovation, but it's sort of the opposite of discipline. It's a freedom to explore and experiment, and we exploit that tremendously. But in a well-defined operation where we want efficiency, we want things done the same way, the military discipline serves very well for both the military program and we bring those skills over into the SHARES program where we get federal civilian and industry people who don't have a radio background, but they learn by example from the very well-trained MARS members, and the MARS volunteers provide the overhead functions, the net control stations, regional coordinators, training nets, net control operators and all. So we get the benefit of amateur radio without having to focus on the needs of the volunteer. We're focusing on the needs of the emergency message originators or recipients.
Okay, great, thanks. Yeah, so I've heard training mentioned a lot here, and I know we've gone out and looked at some of our units and tried to assess them. And one of the things that we've found is just that going out to the field with an HF radio, you're not going to be able to operate it. You need to practice with that thing in garrison and practice it more than once a month. And the units that were doing that showed a lot more competency out there because it's just not something, like I said, it's not just a press to talk and you're good to go. You still have to figure out how to set it up and how to set up your network. And with some of the more advanced like 3G ALE, it's not something you can make up in the field for sure. So a while back we were talking, Vic, and you mentioned something that I thought was kind of critical, especially because I know we have policy, cyber policy people here as well, and I think it's critical to build in your plan HF when it comes to cyber because you can say you want to protect as much as you want, but you still need to prepare for that disaster scenario. And you mentioned a term I thought that was interesting, which was HF as an insurance policy. So could you tell us why you view it that way?
Sure. So I view it that way for two reasons, right? So one is the operational side of it. Those of you, I'm sure a lot of you have heard the term PACE plan. You've heard primary, alternate, contingency, and emergency. Well, and that changes whether or not we're talking U.S. or whether or not we're talking allied. So, for example, U.S., hey, we might have primary, alternate, contingency systems, and HF is that emergency system. Whereas if we're talking to some of our coalition NATO partners, that HF might be maybe a primary or an alternate. So it's relative. But the key thing there is, for the most part, operationally, HF systems are backup systems in most cases, in a lot of cases. So that's the operational piece. But I think that the more critical piece to this is from a funding, acquisition, and policy piece. So when we were talking about it, I said, if you're working HF programs and you're thinking about HF, in reality, you're not in the communications business, you're in the insurance business. And the reason is basically that every dollar that you're investing in an HF program, it means that somebody else's program isn't getting that dollar, or the taxpayer isn't keeping that dollar. And so you're really having to justify it from an insurance perspective, which is, hey, I know that we're spending billions of dollars on our primary systems, but oh, by the way, we need to spend a little extra because, hey, there's these other scenarios where all that stuff that you're spending money on may go away. And so now you have to spend money on this other thing. And frankly, that's an insurance problem. And so from a policy and governance perspective, you really have to approach it that way. I think it's critical because those of you who work on the acquisition side and deal with CAPE and those folks understand that you can't just justify it as yet another communication system. You really have to approach it from an insurance perspective, which is, hey, I have to pay a premium for some policy, and that policy is assured communications. And when we talk about cyber, the other piece to understand is that, if cyber is going to go away potentially, or if satellites are going to go away, you're going to have this out-of-band capability. And part of the challenge that I see is a lot of times people don't understand the technology, so they're trying to funnel TCP/IP through these low bandwidth circuits, and so a bean counter says, well, why am I doing that if I have these 10, 100 gig connections or even 1 gig connections? So you really have to approach it from a hedge against cyber, and I'm going to say this, and it's going to shock some people. Well, maybe if you're trying to hedge against cyber, you don't necessarily have to use IP. So I'll be the guy to say it.
I'll say as IT professionals, you justify billions of dollars in the budget promising your bosses that your IT system will never go down. And who believes that's an absolute guarantee you can make? Well, if you do, you weren't in Puerto Rico 2 years ago when all the communication systems went down. And what was working? HF. 1,000 miles from the island to the mainland or 100 miles from one side of the island to the other. Didn't matter that all the infrastructure was down. A little tiny generator or a 12-volt battery from a car was enough to power that 100 watts to get the message. It didn't even need that much. 25 watts was sufficient to get that message where it needed to go. So a lot of people will take the bet that it's a good expenditure of money to invest in the resilience of your IT system. And of course, that's a smart thing to do. But it's more than a trivial chance that the network will fail. You have several countries that are hard at work to cause that to happen. We have natural disasters, and the most powerful force in the universe, human stupidity, is always a factor in things just breaking. People forget to test the generator. People forget to run the backups. Simple human error is enough to bring things down. So for a very, very small amount of money, your HF radio is what's backing you up to make sure that on that very, very bad day, there's no internet, there's no telephone, no satellite phones. Why would there be no satellite phones? Satellite doesn't have an extension cord to Earth. Well, it's a satellite phone. You're probably calling someone who's on a telephone as opposed to another satellite. So even though part of your circuit is independent of fixed infrastructure, the last mile of that call probably is. So HF radio takes very little investment. There's no recurring cost. There's no airtime cost. You're not charged by the megabit or megabyte or any other unit of measure. You buy it. It lasts typically 15 to 20 years, and it's there when you need it, but it's not an appliance. A lot of folks try to operate HF equipment and have problems because they were only taught how to operate that piece of equipment. They weren't taught about HF. We say HF radio works by PFM, pure freaking magic. Bouncing that radio signal off the ionosphere, going hundreds or thousands of miles. Well, it's not magic, it's science. And to be able to deal with problems, to fix things when they go wrong, you need to understand that. The military used to have very, very good HF schools, but then got mesmerized by satellite technology. And for years, squirrel, shiny object, that was the exciting thing. The people with that HF knowledge died off, retired, the schools have condensed or been eliminated, and you don't have that institutional memory so much. Fortunately, there's programs like Mars and Shares that exist to help get that proficiency back. So one other point I wanted to make, if I haven't run out of time yet, it's close, only 40 minutes to go. Don't think of radio as something distinct from IT, right? To do IT, you have Cat 5 and Cat 6 and fiber cable. That's part of your infrastructure. Radio is just another path for those electrons or photons to travel. It's the medium over which you do IT. It's something you haven't heard a lot about. It's easy to just, well, I'll never need that, or I don't need to think about that. And you probably don't need to think about the wiring in the walls and closets in your building, but you have somebody either on site or very accessible to keep those systems going. HF radio is the backup to the backup. You don't use it very often, but when you need it, it absolutely has to work. But it's part of your culture. It's part of your DNA. It's a path for communications, just like that wiring. So don't dismiss it. Don't think, oh, I'll get to it later, because you never know when the day before is the day before. You've got to have it ready when you need it. So please look into it. Pardon the shameless self-promotion. I have a couple of brochures. They're stacked up here at the edge of the desk. It describes the Shares radio program and electromagnetic pulse protection, another vulnerability for your IT systems. I'm only here today, but there's contact information on the pamphlets. We'd be happy to answer any questions you have.
Oh, that's great.
From the industry perspective, just to dovetail onto that, what I've, or as the chairman of the HF Industry Association, feel uniquely qualified to comment on is the way the industry has adapted what used to be a big, bulky, cumbersome, standalone system, wherever that existed, that is HF, has now, because of automation, sophistication, waveforms, algorithms, like everything else, we have the same things that drive our industry to keep performance high and cost low. We've been able to see HF woven into the regular fabric of everything above it. So rather than thinking of the way we get our information today as a fire hose, if you will, 5G is a fire hose coming at us, and when that fire hose breaks, whatever caused it to break up and down the stream that allows it to deliver that fire hose of data to us, voice data, what have you, we go from everything to nothing. What we've been doing and the industry's been doing with the sophisticated techniques and automation that the techniques have brought to the industry is weave that medium into the regular fabric so that as things break, as that fire hose breaks, instead of breaking and going to nothing while we try to fix everything, we end up down to about the garden hose level, but we still have something coming out. And so we have a more seamless what we call fallback. We don't call it failover. Failover would imply that whatever we're using, we fail to something else that provides us the same level, but just another way. We fall back to something that still works at a lower level, but still works and gives us what we need for mission critical support and command and control in the case of military, while we fix the everything. And in many cases, in parts of the world that we work in, this stuff is used, as Vic said in the PACE analogy, it's used at the A and the C level rather than the E level because of either cost constraints or extreme disparate geographies, especially you talk about the Pacific Islands. In many cases, there's fiber running across the ocean, in some cases running through some of these island nations, and it actually never gets landed there. It goes right through. So they have no real effective means beyond either SACOM, and of course over water, there's issues with rain fade and high atmosphere disturbances that can cause your SATCOM to also not work very well. So again, HF, because everybody talks about the ionosphere, but keep in mind, HF radio also travels across the ocean very nicely. Doesn't even have to leave and go into space. Just travels across the ocean very nicely. That's why the Navy still uses it quite a bit. Navies around the world. So the industry has embraced the advances in the technology to weave it more seamlessly. Instead of it being a big box that sits over in that corner, when this stuff here breaks, we go over there. It's already there in some way, shape, or form, so that if you pick up your phone and you dial out through the regular telephone switch, for example, and you can't get through, you might dial another extension that goes to that radio wire interface box that now dials the phone call and transfers it over an HF. And because of digital voice, it sounds pretty darn good. And you don't even know, other than the fact that you talk and they listen, and then they talk and you listen because it's a half duplex, everything else still works. So you'll find that in many places that's what's been happening, because things don't break everywhere, they break somewhere. And all we have to do is communicate from the somewhere that they're broken to the nearest elsewhere that's not. And then we can get back to regular infrastructure the rest of the way. Let's face it, if everything's broken, we got another problem. Well, if that happens, we still use HF too. In many cases, most of the HF that our military's used since about the end of World War II to today was your doomsday HF. That's really where it existed. But it's not just that anymore. It serves a lot of other purposes. And our doomsdays, a la the Cold War, are low probability, massive impact events, a la nuclear weapons, but we're more likely to see a higher probability, medium to large impact event, like denial of service and anything RF weapons based, that are easier to do and more likely to happen and affect widespread areas of communication infrastructure.
Yeah, and I think we've been talking about satellites, not just degrade or just having them either go out completely or being hacked in cyber, but also, as we've actually already seen, is just jamming. I mean, if you think about a satellite signal, it operates at a pretty low power. It's direct line of sight to the satellite, but any kind of interference that comes across that, it can take it out, and we've seen that in theater. And HF was the backup when that happened, and that was the only time that we were able to recover. So that's interesting. Ross, I think you've mentioned a little bit about critical infrastructure. What are some of the aspects that Shares does as far as integrating with like the power grid and some of our critical infrastructure in the States?
So whether it's power company, water, internet, telephone providers, they have massive networks. And if they had a large-scale outage and they have to coordinate multiple points or even end-to-end on the extreme ends of their network, how would you do that? Your first instinct is to grab the cell phone, but the cell phone is part of the system that's probably impacted here. So HF radio provides point-to-multi-point as well as long-distance end-to-end, and it has none of the same failure modes, none of the same dependencies as any other communication system that you want to use, whether it's wireline telephone, voice over IP, cell phone, satellite phone. They all have common failure points. Commercial electric power primarily. Interesting thing, did you realize that the telephone system depends on water to work? Most telephone equipment these days is computer switching equipment, it's routers and switches and hubs and so on. And that's in buildings, and that generates a lot of heat, which is dissipated through chilled water coolers. So if the water system is down, no water after a few hours, no dial tone. You don't realize all the, not only dependencies, but interdependencies among systems. So the unique thing about HF radio, the ability to go long distance with very modest power, that little UPS under your desk has a 12-volt battery, most likely will power an HF radio for a while. The critical infrastructure needs multiple backup systems, and they are starting to realize on their own that HF radio is something that they've overlooked for too long. They were dependent upon satellite technology as their backup, and they've seen recently 2 countries shooting down satellites in orbit and the persistent threat of cyber attack, that satellite is not the ultimate answer for backup communications. No one mode of communications is the ultimate answer. Every system has its strengths and its weaknesses. Every system has its vulnerabilities. It's not about which is the best tool. It's about having the right tool for the right job at the right time. And HF radio is one of those tools that you should have. It's a very low-cost tool to add to the toolbox. So in addition to the utilities providers we mentioned, think about hospitals. Hospitals typically use just-in-time inventory system, as does your supermarket. With a hospital or a supermarket, normal times, they have a 3-day stock, okay? So imagine some disaster, maybe just cuts off power, cuts off transportation. There's no trucks rolling down the road to resupply. In 3 days, your hospital is out of business, your supermarket is out of business, no Doritos, we're all in a heap of hurt. So to address part of that, if your hospital has a way to communicate with the supply warehouse on what supplies are needed, assuming the roads are open and fuel for the trucks can be pumped, they can get what they need and keep the supply line open for the critical function. Likewise, power generation facilities, if they're dependent on coal or they have to coordinate with natural gas provider or whatever backup fuel source they can use, they need communications to coordinate with the supplier. It's not get on your bicycle and ride to the other side of town. You're talking hundreds of miles typically. So HF radio on both the supply side and the demand side can keep the critical factors of society going long enough for the big infrastructure systems to get restored. So a lot of these folks who you don't think of as typical HF radio users have become more aware of their vulnerabilities, more aware of the limitations of the backup systems they've relied on in the past, and without a lot of marketing on my part, they've found their way to the shares program, or some of them are eligible to directly license through the FCC, Federal Communications Commission. If you're military and other federal agencies, you're not eligible. If you are telephone, pipeline, internet, or oil exploration, those are the only industries that can get HF radio through the Federal Communications Commission. If you are a transportation company or a hospital, you're just not eligible. There's no avenue there. The shares program is available to a lot more than the traditional federal agencies on one side and those limited network industries on the other.
There's another critical infrastructure that Ross forgot to mention that uses HF in a primary mode and would impact your ability to travel very immensely if they couldn't use it on a regular primary mode basis. Anybody want to guess who that is? Anybody come here from overseas? Any plane that leaves land and gets off radar, which isn't very far from any terrestrial-based FAA in this country, and VHF range of those radios that the plane talks to the ground with, they all use HF every single day. And it's so important that the International Civil Aviation Authority actually dictates that if there's a geomagnetic disturbance in space from the sun that affects the ability for HF communications to be had, plane always has to be in touch with the ground, wherever it is when it's in the air. And if there's a geomagnetic disturbance at the poles, which happens sometimes quite a bit, and it causes there to be an outage, meaning there'll be a blackout for a couple hours, like Ross said, not all the time, but that plane cannot fly a polar route from the US to the UK, which is the shortest route for fuel and everything. So a lot of times flights are canceled and you don't know why. It's probably might be because of an HF outage. So HF is still used very, very heavily in places that you don't think about that you, and that's a major critical infrastructure. Any plane going anywhere over water, not just over a lake, let's say the Great Lakes, but any ocean, they have to have HF. And not just one, they usually have 3 HF radios for redundancy. They even have to have backups for their backup to make sure that that plane can communicate with the ground, because there's no radar, and they're able to call in their position and turbulence too, by the way, because they can't see air turbulence and radar. So they actually call in at various waypoints to let the ground know where they are, how they're doing, and if there's any turbulence at such and such altitude, and get a position or authority to go higher or lower. Just FYI. So.
Great, thanks for that. That's interesting. So speaking of plane flights, I was in SICOM, Estonia, and one of the talks that was given there this past SICOM was something that I found it to be fascinating. It was disrupting a satellite without having any ability to do satellite operations, and what it came down to is we actually track not just the satellites, but we also track the space debris. The space community does, and it's stored in these things. And I know from a ham operator, we use the 2-line element, so we just download the 2-line element, which gives you all the data you need to be able to figure out where the satellite is. If you ever look on your phone, you want to see where the ISS is, you can do that, and it's done through these 2-line elements. And so this attack was interesting, is what happens if somebody hacks into that database where the 2-line elements are of just the debris and like shifts it off a little bit, and then some of these bigger satellites that normally could steer away from debris can't steer away from it. So kind of an interesting cyber attack to that. But speaking of the denying satellites, there's just all these different vulnerabilities that people are inventing and coming up with that are ever present. So, but also with that, like I said before, I think the internet does complement HF radio quite a bit. And as you were saying, going down from the fire hose to the garden hose. And I know one of the things in science has been real fun, even for myself as a hobbyist, of looking at what's called the reverse beacon network. So if I transmit a signal and a certain digital signal, I can go online and I can see all the different people that have heard my signal. And it's it's fun to do just as an individual, but scientists can use this to also monitor the ionosphere and look at disturbances and these kinds of outages when these events are happening. I know there's a whole HAMSci group that I'm a member of that's working on. They actually are real fascinated with what happens in the ionosphere during a solar eclipse, because it goes haywire because it's not being charged like it normally is. So it's pretty fascinating. But going with that, John, tell us a little bit about some of the integration with the internet and ways that you've been able to kind of do things that maybe it's just a local outage and you're not taking everything out, but you can use HF to kind of get out of there. I mean, there's just all kinds of aspects.
So just as an example, one of our products and company that we're heavily involved with comes from Australia, and there's a number of HF companies from Australia, and people wonder, why is that? Well, there's still a whole heck of a lot of nothing in the interior of Australia, and there's not a heck of a lot of infrastructure to support a whole lot of nothing because it's too costly. And HF is still used heavily in primary mode, so we've been able to link the radios, put them in remote locations, and provide at least some form of IP path, whatever that is, whether it's fiber in the ground or SATCOM or whatever, which minimizes the amount of SATCOM circuits we have to have just by connecting those 3 or 4, let's say, base stations that are spread across a gigantic area, maybe the size of Texas in the case of the state of Queensland and Australia. And the regular Australian ambulance service, just like your local AMR, when they roam outside of the cities, which are the coastal areas of Australia there in Queensland, they're out in the middle of nowhere, and they have to cover gigantic areas. So rather than put the burden of a fairly skilled healthcare professional in the form of an EMT, but not necessarily a radio operator, to have to figure out, well, which station do I call to get through to then route back to the headquarters, for my command and control for the medical service, they can distribute the radios for diversity or for voting, let's say, over gigantic areas and have remote access to those stations over an IP connection, and then see on a console, let's say at the headquarters in Queensland, all those stations, so when that ambulance makes that call, whichever one picks it up gets it. So they've simplified a very complicated circuit path that has to be made or would have had to be made in the past in a very manual, skilled fashion, fully automated by having remote connectivity to those radios by other means, because they're not being used in a failback or fallback, I should say, mode. They're used primarily when those ambulances roam outside of what is normal covered area that's just too costly to build microwave links and lay fiber to connect 65 cell towers just to cover that ambulance when it goes 300 miles or 300 kilometers away to some cattle stand one time. And they're able to actually integrate the best of both worlds, the internet with the radio. Or in the case of what we did with Colonel Hamilton at West Point, we just showed him how our ability to remotely monitor ourselves and not have another person on the other end by connecting to the radio in Virginia by the internet with our phone, and then talking on a radio in his office and listening back through. I mean, so you can sort of percolate in your head all the things you can do if you can marry the technologies together in a best practices way for regular use, or use when things aren't broken everywhere, as I said a moment ago, but they're broken here and not there. So you can still use other paths or other infrastructure that might still exist, but use HF in the area that you've lost your primary means.
That's great. So, that's the exciting side. I guess I have to look at the cyber side of this now. So this will go to either Vic or Ross on this one. Is so when you start connecting, and I'm sure we have some information assurance people in the room that get nervous when somebody brings a new black box to plug into your network, and then you don't know what it does, and you have to do some kind of risk management on it and figure out what you want to do. What are the challenges, and how are we going to overcome them of integrating these networks? And you mentioned, and I'd love it maybe if you could talk again about what do you mean by when you just don't use IP? Like how does that work? You're communicating without IP now, which makes some people happy because then there's no open ports and everything.
Well, sure. So one of the challenges that we had within some of our programs that I supported and was how do we in the DoD, say for example during a DISC event, how do we start talking to other people? And sure, we have this really cool type 1 encrypted stuff and it works really well in our enclave, but now I have to start talking to other people that are zones of no trust. So how do you do that? And again, if the DoD is going to fund all these people and give them stuff, okay, maybe, but then a lot of their people aren't cleared. They're state agencies or civil authorities. So you get into that kind of gray area. And so we kind of had that problem to solve, and we worked with the Sheriff's Program to figure out kind of some ways to do that. And what we really looked at was essentially protocol diversity. We really said, okay, well, if we have to talk to these people and we just can't come up with a common way that we could do it safely, because at the end of the day, it's about accepting risk. And so the commander was very specific that didn't want to accept additional risk, especially in the cyber area. So he said, well, who says we have to use TCP/IP? And so we went back a little bit old school and said, well, why don't we just do text data, serial data? And we looked at the existing MIL standards in HF, and they have built-in error correction mechanisms. And so we did that, and we're able to communicate with folks. So there is no TCP/IP. It's completely out of band, and that was another thing, is that we were able to leverage it as an out-of-band solution amongst ourselves. And so we worked with Ross. I'll turn over to Ross, because we just developed some TTMPs that we could have in our back pocket when we did need this interoperability. It's not anything that necessarily we needed day to day, but if we needed it, we had it.
All right, so I'll address a different aspect of it. When you go to your IT security people and you say, hey, I want to connect the radio to the enterprise network, they start at no and then they go negative. They view this as a backdoor that's coming in behind the firewall, behind everything else, and anybody out there in radio land is going to connect to your station and run wild on the network. So with the normal approach of no, you're not allowed to do that, we drop back to an old tried and true technology, SneakerNet. Message comes in on the radio, goes into a computer, workstation, or laptop, and we copy it to an approved thumb drive, and then you bring that thumb drive across to the enterprise network, and as soon as you plug that thumb drive in, it gets virus scanned and checked, and then you can cut and paste or copy the file and forward it along. For text messages in the data communication system that we use in shares, which is called WinLink, when the message comes into the computer connected to the radio, it's configured to forward that message over a commercial Wi-Fi hotspot out to the internet. We're assuming the disaster is somewhere else and the internet is working near our office. So it goes out to the commercial internet and it comes back into the enterprise network the same way any outside email comes in, through all the firewalls and IDS and all the other protective devices, and it shows up on my smartphone, for example, on my work account. So during Hurricane Maria in Puerto Rico, 11 o'clock at night there, a guy decided to send me a spot report. And I'm at home in bed and I hear the cell phone buzz, and here's a message. It came into my office. Nobody was in my office, no one operating the radio. The message came in, it looped back out, came to my home. I read it. I forwarded it to the 24-hour watch center. So with about a 1-minute delay, you know, it got where it needed to be instead of waiting until in the morning when the information might have been stale. But that was a way, without upsetting the IT security people, we found a way to interconnect a couple of systems and get the message through. If you're starting from scratch, if you're not fielding an approved system, there's lots of requirements, certification, accreditation of the hardware and the software, and so on. But if you're starting from scratch, I think the key to success would be getting an IT security person assigned to an integrated project team, or whatever the buzzword today is. And that person has to be told, this is not like your normal job where your job is to say no, protect the network at all costs, even if it means not executing the mission. Your job is to find a way to make it work, right? As a member of the team, it can be done. It has been done at numerous federal agencies, but no one will share that information because if the bad guy gets a hold of it, now they know what the protective measures are. So it has to be done as a team sport between the communications people and the program people, whoever has the requirement for emergency communications, and the IT security people, where they're a partner, not an adversary in getting this capability working within the enterprise.
Oh, that's great. Thanks. Yeah, I know you mentioned the hurricane a couple times, and I know that I think ARL had a call out. I got the message to all the ham operators that they just wanted volunteers, and within like hours they had like 50 or 100 people and flew them down there to operate. It was pretty fantastic. I feel like all of our real lessons learned, life lessons learned in HF sometimes is some of these natural disasters. And I know in the last talk, I think there was a mention of Nepal with the earthquake that happened there. And we got a chance, ACI actually sent a small team there last year with Indo-PACOM to do a, how do you communicate when the infrastructure is down? And we played with our HF radios. That's when I realized I didn't know as much as HF as I thought I did. It's actually really difficult to operate within a city, because then you have buildings and there just seems to be other challenges for it. So it looks like we're getting close to question time. So unless we have any closing thoughts here, we can open it up for questions.
Question?
And it really is difficult to see
I
up
see
here.
a question over here.
Okay, 4. I think we'll go with 4.
Dave Wilson, Army IG. In the operating HF and tactical environment, have you run into the same RFI noise problems like you would operating a station from a suburban environment? And if so, how have you overcome that?
Yeah, I think.
Yeah, I'll start. That has always been the case, and as Colonel noticed, we also spent time in New Guinea this year for another exercise of Indo-PACOM, and that is a typical problem. And again, and I would say metamorphic, because they really are, advances in the way the signals are transmitted in codecs. Actually, today, the digital voice technique works better than just clear, old-fashioned sideband in a high noise environment. We're even able to affect communications on channels that there's something called wave height radar. It's called CODAR. And among the other noises and beeps and bloops you hear on HF, these tend to occur down low on the channels you need at nighttime or early in the morning. And we're able to actually affect communications and create circuits where normally that RFI he's talking about, radio frequency interference, everything from fluorescent lights to solar panel inverters to a gigantic hotel that's generating untold amounts of noise, we're able to communicate in the presence of that, where before it was very, very challenging to use HF. And today we can. And the data transfers are even better, because when we're sending data over HF, we don't even need a synchronous connection. In other words, when I'm talking to you, it's synchronous right now. With data, we can just keep sending it in blasts, repetitively, and maybe it takes 3 tries to get through, but it'll get through. And what do you know, whether it got there the first time or the third time, all of a sudden the message shows up in a high noise environment.
And so part of the problem you describe is the difference between training personnel how to operate the equipment and training people to understand the theory of HF radio. When you're trained in the art of radio, you understand interference sources and mitigation techniques. It may be simple as move your antenna farther away from the generator or the vehicle with the noisy ignition source. But if you're just trained to operate the radio, you're okay with volume and channel and squelch, a little bit iffy, but you don't know these other techniques. You don't know how to recognize problems, how to identify problems, how to describe problems, and sometimes how to solve them yourself. So as we move back towards HF, we need to move back to the older type of training where it's not just how to operate an appliance, but how to understand the field, the physics. We're not talking PhD physics here. We're talking a couple of hours or a couple of days of training, but it's more than what most people seem to be getting now, which is simply equipment operation rather than system-wide operation.
We call it MacGyver training.
Yeah, I think so. So we've run into the same challenges in the past, and part of it is because a lot of the if improvements were industry-driven, and the government side kind of went a different direction. So they went down the road of SATCOM and landline and wireless, and so they didn't really provide a lot of guidance to industry. And so this is one of those cases where the theory of it is great. You're able to take what used to be 1, 5, and 10 kilowatt transmitters and effectively communicate at the same level using 400 watts because of the processing gain of the waveforms. Theoretically wonderful. Operationally, they kind of forgot that, maybe the guy next door has a grow house, and now it's interfering with all your stuff. And so what we had to look at was going back to, I think maybe a little bit what Ross is getting at, is system architecture. So is that station that's talking to the other station, does that guy really need 25 watts, or maybe that guy should be at 400? Maybe we need to go back to a 1 kW transmitter. And so I think we were able to solve a lot of those issues that we ran into by really reevaluating what the requirements were, which is what I think the key policy piece is what are the actual information requirements? What is the end effect that you were trying to achieve as the warfighter?
I'm going to play lawyer here and argue both sides of the issue here. On the other hand, there have been tremendous strides made in automating some of the art and magic of HF radio. A technology called ALE, Automatic Link Establishment, takes a lot of the smarts the operator used to have on selecting a channel, at what time of day and under what conditions do you use which channel for which distance. And a lot of that has been automated into the radio. So now you need one smart guy to set up the network, to decide which group of channels to use and a few other parameters. And the radios will talk to each other. In internet technology, we have a ping that you send out a little signal and you measure how long it comes back. There's an equivalent in ALE radio usage where a station sends out a signal and the other stations on the network measure that, and they remember how good a signal it was at what time of day on what channel. So when you want to call John, you go to the radio and it's just like your cell phone. If you can call someone from the contacts on your cell phone, you can operate an HF radio. You look down the list of the person or station you want to call, you poke the button, the radio already knows what's probably the best channel. And if that doesn't work, it knows the second best channel and the third best channel. The radio establishes a connection with a little handshaking, and then when the two stations can hear each other digitally, the radio will say linked or connected and open up the speaker, and now you can talk. So when you're not actually in a conversation, the speaker is cut off. You don't have to listen to static and noise and all the other things that you might think HF radio is like. It's just quiet. It's just like a big, ugly telephone sitting on the receptionist desk in the office.
Well,
and when it goes beep, you know to answer it. And when you want to call someone, you just poke a button. It's literally that easy.
In many cases, that radio is connected to your handset through Wi-Fi in the building that it's in, and you still use your phone as the actual interface. You actually open an app, you're still using your handset as the interface.
And another one of those technological advances is in my office, the radio is in a radio room, and my office is somewhere else on the floor. If I'm not there when the call is made, that radio connects through the Wi-Fi to my smartphone. I can be sitting at my desk and I can initiate a connection. I can talk on the radio just like I'm talking on my smartphone, because I am talking on my smartphone. It's going through Wi-Fi and an app, connecting to the radio, extending that radio, making it more available, not just to the radio operator sitting in front of it, but to anyone within Wi-Fi range of that device. And that can also be remoted across the internet, depending on vendor and their options, so that you can be 1,000 miles away from that radio and still operate as if you were sitting right there. So when everything is working well, it's an appliance. It's a very friendly appliance. It's easy to use. When something breaks, it requires some specialized knowledge to fix it. That specialized knowledge is not as common as it once was, but it's not like it would take major investment to recover that knowledge, just to bring back some of the training courses we used to have.
Okay, great. Another question, 4?
To what extent do our adversaries, in the event that the catastrophe is not of natural causes but of adversarial maleficence, to what extent do our adversaries have the ability to impede, jam, or override signals through HF? And to what extent can we keep the lines open over the attempts of our adversaries to shut them down?
So I'll try to take that. I think, yeah, so the capability to jam HF has existed since HF radio was invented. So not getting into specifics, yes, the capability exists. I want to take that question as kind of a segue into something that I think is important for the discussion, which is collectively, we need to agree on the threat. And I think that that's a big challenge that I see right now within DoD, is that, you know, we talk about, hey, we're here talking about satellite denial. What exactly do we mean by satellite denial? We're talking about cyber denial. What does that mean? Does that mean one system goes down? Does that mean all systems go down? And I think it goes to your point, which is, okay, well, is there going to be denial of HF? And I don't know, I don't believe, this is my personal opinion, I don't think that DoD-wide and NATO-wide we have standardization on what that means. And I think that's so important, because I don't think we can plan for systems unless we answer those questions in a way that we all agree on.
Yeah, on the specific of HF radio jamming, if I'm in an HF conversation with John and you're some distance away jamming, his signal is much stronger to me than your signal. And you can increase your power and you can try to jam us, but your effectiveness, now if you're right next to the receiving station, you'll be very effective. If you are in between or somewhere else, it's hard for you to effectively jam because I may have a directional antenna pointed at him, he has a directional antenna pointed at me, you're in the null of our antenna, it's hard for you to be effective jamming us. And even if you are effective at jamming us, different frequencies propagate different distances at different times of the day. So if we're communicating at the peak of the day, we're on 14 to 16 megahertz, and you're some distance away, and you have very good propagation, you'll jam us. But if we're relatively close together, we can go to a different channel, 10 megahertz, 8 megahertz, 6 megahertz, 4 megahertz, where your signal isn't even propagating to where we are at that time of day. Now, later at night, your 4 or 5 megahertz signal is going to go farther. You might be able to jam us on that frequency, but it's very difficult to jam every frequency, every location at the same time. So HF radio has that advantage of diversity through the frequency diversity means you have different propagation characteristics, making a single point jammer less likely to be effective over a wide area over a large number of stations.
Let me add one thing to that. That's why the LPI LPD I think is so important. You were mentioning FT8, and there's some STANEGs out there that talk about LPI LPD, and that's why I think those waveforms and that technology is so critical. Because yeah, right now things can be jammed, but if you don't know where people are or they're underneath the noise, how do you know where to jam? So that's why it's so critical.
Yeah, can we for the crowd just let them know what LPI?
Low probability of intercept and detection,
Yep.
or whatever. From the industry, I can tell you, nothing's impossible, as Vic said. It's harder to jam an HF circuit, broad spectrum. And as somebody told me from the military one time, the life expectancy of a jammer in the battle environment is that of very, very short. And so it's harder to do. It's easier to overcome, and there are techniques within the military HF world that are counter measures to jamming. So it's one of the better methods of communication. But as of course, nothing is off limits, but it's just harder to do and easier to overcome. Yeah.
Okay. Any more questions? Okay, great. I think we're right on time here. So,
One last thing. So,
okay.
so I think one month till Navy beats Army. So
that's what we get when you have a Naval Academy.
I know,
on
right?
stage.
Yeah.
Yeah, exactly.
No love.
So great. Well, thank you very much for coming.
Yes, appreciate it.